Just 1 second.
हाँ ना पाते रहा
I think for Jane it is like 4 a.m. in the morning. He is from I think Dubai or Saudi Arabia. So anyway, let me just start this. I think my screen is already shared. So we'll start with storage basics because some people may not be from storage background. For them to understand the L2 concepts or any storage, they need to understand about the basics. In any of my sessions or any of the recorded sessions that you can see, if you have any doubts, then you can always ask me, one to one or over the group. Okay. Yesterday, one of my student, Pritam, he reached out to me for a fabric performance issues. Okay, so you can reach out to me for different things. Okay, so anybody pinged or what? I saw a message, Okay, so let us start. Okay, so if in order to understand the storage basics, you have to understand how data is physically stored, means the hardware part. Okay, and also you need to understand how data is logically organized, the architecture part, right? I think you can, yeah, you have accepted him. Okay, so welcome everyone. Okay, so initially we'll have the storage basics and the switch concepts, and then we'll move on to the NetApp concepts. First we'll complete the L2 training, and the L3 people will continue with the L3 ones. Okay, and the L3 training will always be different in every batch. 5 concepts, 5 new sessions will be there. Okay, new sessions, but L2 will be almost similar. 1 or 2 sessions may be different, but almost similar. Okay, so when you're talking about how the data is stored, right, the hardware part, right, you have to understand about the physical layer. Okay, so you have your hard disk or hard drive, right? So basically you will have some magnetic splatter that will spin. Okay, and basically it's nothing but it's using a moving read and write head. It's kind of like a record player. Okay, this is something we used to use long back. Nowadays also use it, but nowadays discs are very cheaper. Okay, so this hard disk, right, like SATA, SAS, these are very cheap, and you can have large amounts of data like terabytes. But there are some problems with this kind of mechanical hard drives. It is very slow because of this mechanical movements. When you need to read the data, when it is not in cache, you need to read the data from the disk. Then the platter or the head has to locate the data on the sectors, and it takes some time. Okay, and that is called as that attributes to the storage latency, and your application will feel latency issues. Okay, so that's why for the mission critical applications you really don't use hard drives, right? Because hard drives are slow, it is noisy, and also it is having moving parts, right? And the moving part, it can wear and tear, right? Means the prone of failure of hard drives is quite high. Okay, and then you have other one which is SSD or FMD, solid state drive or flash module. Okay, so basically it uses flash memory chips. It does not have any moving parts. It is much faster than your mechanical hard drives. It is silent, and it is not prone to failures. It does not fail often. Okay, if you're using if you're using hard drives, mechanical hard drives, if you're using SSD, then you are already aware which are the disk that fails the most. Okay, and then you have NVMe, non-volatile memory express. Okay, so NVMe, it does not have a like it's not a different chip, but it's a faster protocol. Okay, it does not have a different chip compared to SSD, but it's a faster protocol. So when you're using standard solid state drives, right, you are using old SATA bridge, which was basically first implemented or came into existence because of your mechanical hard drives. And NVMe, non-volatile memory express, it will directly talk to the your control processor units, CPUs. Okay, it already talk to the CPU. And NVMe is basically much faster, 10 times, 35 times, like 10 to 35 times faster than a standard SSD, which is using SATA interface. Okay. Now there is one more thing you have to understand, which is basically the logical part: block, file, and object. Okay. So block is means basically you have like a lot of data, right? It's like on block, kind of like different blocks. So it depends on which kind of storage you're using, whether Hitachi, NetApp, or EMC. Depending on the block size will differ. Block storage is nothing but the SAN, storage area network. So what we use in SAN? Basically, when you're using SAN, right, we are basically using dedicated high performance fiber channel network. Means we have a array that supports the SAN protocol. We have our SAN switches, either Brocade or Cisco. We connect the storage front end port to the switch port. Okay, and the switch will be in core edge fabric. I'll discuss about this in detail when we begin our switch sessions. So what we do is, at the core means the central part of your fabric, you have your director switches, which are much more expensive, and hot swappable means if any of the things get damaged, right, like faults get faulty, right, like let's suppose management port, you can replace it without getting a downtime. So hot swappable, hot pluggable, these terms will come into mind, okay, when you discuss about that. And you always use redundant fabric, means you have two fabrics, fabric A, fabric B. In fabric A you will connect host HBA, like suppose you have a host like server 1 and it has a HBA like HB1. Okay, so let me show you what we mean by this. Images. Okay, this is what I mean. Okay. Okay, so this is your, let's say this is your Hitachi, NetApp, or EMC devices. You have your storage front end port. You're connecting the storage front end port with your Brocade SAN switch. And why you are doing this? Here it is showing only two switches, but it is never two switches. So here one switch, it can be like hundreds of switches in fabric A and other hundreds of switches in fabric B. And the zoning database of fabric and fabric will be different. You will not connect this with any fiber cable or ISL connections, because that will do fabric segmentation. Okay, fabric merging it will do. If it does not have a same zoning, then it will do fabric merging, and if it has the same zoning, it will do fabric segmentation. You don't want to merge the fabric between this. Okay, so why here we are using two different fabrics? Why? Fabric means collection of switches, because let's say this fabric fails, right, then another fabric is there. So we are using this for redundant purposes, for high availability. We don't want, like, we want the server to have the access of storage at all times. It is called as, in storage term, it is called as high availability, redundancy. We do not want any single point of failure. So here we are eradicating the fabric level point of failure, and here also we are using 2 HBAs, right? So if one HBA fails, here 4 HBA is showing, but let's say 2 HBA. One HBA fails, then another HBA is there. In storage, sorry, this is storage, right? In server you are using, right, HBA, one HBA fails, another HBA is there. Storage, one front-end port fails, another front-end port is there, right? Here what we are doing, one initiator means your HBA, and two target, two front-end ports, right? So the zoning is part of 1:2, one initiator, two target. Zoning means your relationship between your server and storage. I'll talk about zoning, okay? Means you are making connection between your server and storage. See, if you are not using SAN like earlier days back in 2005, 6, 2, right? There was DAS. There was DAS, DAS is direct attached storage. So here what you are doing, you are directly connecting the storage to your server or host. You do not have any SAN switches or any kind of network switches in between. The storage that you're using, right, it can be an external storage. You can connect the external storage directly to your server, or it can be internally. Is in case of ESX, right, you have this ESX will have your own internal storage, right? AX box, your HSMP clusters, they will have your internal storage, right? So that is also DAS. But if you're using external DAS, right, it is easy to increase or expand the capacity. If you're using internal, then it has its own limitations. Okay, so what you're doing, you're not using any switches in between, you're just directly connecting the SAN switch with your server in DAS architecture, and that's what it is doing basically. So one front-end port is being used for only one server, right? That's the limitation. But if you're using SAN switch, you are connecting one front-end port here, you are connecting HB here, the same front-end port you can use for multiple servers. So your number of devices per fabric is increasing, which will be it depends, I think one switch supports 255, I think. So we have to check the number. You just check my earlier videos, for the number, like how much a fabric can support, like how many switches it can support, and how many host or front end port a switch can support. It depends on the ports on demand license that it has, right? Two kind of ports on demand license Brocade SAN switch has. One is fixed, other one is dynamic. We'll talk about in switch sessions. Okay, so we talked about DAS. We are talking about SAN. In SAN, what we have, you have your storage device, you have your HBS, like server HBS, you connect them to your SAN switch and you do zoning between them. Okay, and here all the cables that you see is, these are fiber cables. These are fiber cables, FC cables. Okay, and the switches that you use, right, as I said, core, edge, fabric. At the core you'll have your director switches, which are having lot of ports. It has less limitations on part of switch port or any kind of licensing. But at the edge of the fabric you will have your fixed port switches with which cost less. And in your edge switches, which are fixed port switches, if one of the switches fails, like if if the management port of one of the switches fails, then you have to replace the entire switch. And I have been doing this for every not 3 to 4 months, but almost like 1 year, every year. Okay, because sometimes we are not able to access the switch because the management port is faulty, because the management port will assign some IP to it, and using that IP will manage it remotely. My data center is in Switzerland and I'm in India. How do I access the switch, right? I cannot go to data center and access the switch, right? I have to access it remotely, and that will be done from the management port only. If the management port is faulty, then the entire switch has to be replaced. Okay, but in case of director switches, if the management port is faulty, you also in fixed port switch you only have one management port. In director switches you have two management port, and even the two management port is gone, the management port, it can be replaced. Okay, and it is hot swappable, hot pluggable, means you don't need to require any downtime to replace this. Okay, now what is the basic component of SAN? SAN is required fiber channel switches. So you need to invest money on buying this fiber channel switches, fiber channel cables, and this will increase the initial cost of investment. Okay, so your data center investment will increase if you're using SAN. Okay, in earlier days we used to use a lot of SAN. Okay, nowadays they're using hybrid storage, like they're using SAN, like NAS. They don't use DAS nowadays. They use object storage such as Amazon S3 or storage grid. In EMC, like I think it's ECS. I've not been working EMC for the past 8 years, so only Hitachi and NetApp. Okay, so and you also have your cloud storage, which is kind of NetApp is having a collaborative solution with different multiple like cloud vendors like AWS, Azure, and GCP. They have cloud volume on tap for all the cloud vendors, three vendors, and then they also have FSx on tap, Azure NetApp files, GCP NetApp volumes. I have shown this in all of my L3 batches, right? Okay, and then so these things you need to understand. And then one more important thing about this just to be different storage technology that is available is NAS. Okay, network attached storage. So let me go here. So you have your SAN, which is block storage, you have your NAS, which is file storage, and then object storage S3. Okay, so in NAS you basically have normally in earlier days what I used to do is I used to allocate the storage from Hitachi or NetApp to Linux server. We used to make the Linux server as a NAS server. Okay, like we used to make entries in the slash etc slash exportfs. But if you're using Linux server as a file storage, then it has its own limitations because it is a server, right? It's not storage. It does not have high processing capabilities. So what do you do instead of that nowadays? We purchase NAS headers. Okay, for NetApp it's not really or it's not, there is no distinction. When you're purchasing a NetApp box, FAS or AFF, FAS is basically a hybrid storage which will have, you can use different kind of disk like SAS, SATA and SSD in FAS. But AFF is all flash array, so all the disk will be flash only. Okay, NVMe or traditional SSDs. Okay, so basically when you're using a NAS array, right, let's NetApp or Hitachi, HNAS or EMC's Unity or VNX, then what do you do here? You are using this for shares, CFA shares for your Windows servers and NFS for Unix. So what you are doing basically, you are putting a file in a centralized locations, and you really do not want high performance for this, because the critical applications that requires high performance, low latency, very good response time, you need to use block storage, the storage area network for that, the SAN protocols. Okay, FC protocol. Okay, iSCSI is also there, but anyway iSCSI is CSI. iSCSI is basically use network infrastructure for this, use Ethernet switches. So whenever using NAS, you'll be using Ethernet switches with your NAS array. Okay, and your network team will have some work to do. Okay, they need to create routing, the VLAN, all these things. Okay, but your NAS is always depend on network, and the network can have latency issues, can have performance issues. So your performance, the throughput, it will be lesser in NAS. But every technology has a different purpose. For uh, applications that requires lesser throughput or IOPS, you can use NAS, the file the file storage. Okay, And then you have object storage, which uses S3 protocol. S3 protocol is nothing but, Amazon tells it, that is simple storage service, 3 S's. Okay, so here what we do, we keep the data like in object storage. Normally what we do in case of storage grid or Amazon S3, it's quite similar. The concept is quite similar. We create tenants, and inside tenant we create buckets, and we upload the objects into the buckets manually or using some S3 command, okay, in through AWS CLI or whatever external S3 application you're using, or storage grid, okay, it depends on that. But basically what you need to understand that object storage can be, it can be dispersed into geographical, geopolitical locations, okay. You'll think that it's the same storage, but it can be in different places. Like when you use AWS, you see different regions, Virginia, East, West, a lot of regions, right? In case of AWS, Azure, or GCP, okay. And then you have one more storage. I forgot to tell this, okay. That is SDS, software defined storage, okay. Every vendor is having different software defined storage. We are talking about NetApp here, so NetApp is having, it is called as ONTAP select, okay. So here what we do is we basically use some third-party storage. It can be NetApp, it can be Hitachi, it can be EMC. We zone that with our ESX arrays. ESX arrays will have, not sorry, ESX server. ESX server will have its own HBS. So we just connect that ESX with SAN switch, preferably in the fixed port switches, and the front end port we connect to the edge switch, like core switches, which is the director switches, and we do the soft zoning, the WLPN based zoning between them, amongst them, and then we allocate the storage from the external array. It can be Hitachi, NetApp, EMC, and then we instruct the ESX team to create the data store in the ESX, and also we download a OVA file, the ONTAP select package from the NetApp support site, and we give it to the Intel team or the ESX team. They will create a VM out of it, which will be deploy VM, and they'll give the IP to us, and we'll create ONTAP clusters, ONTAP select clusters, from using the deploy. And the ONTAP select cluster must have the admin privilege of the ESX server, because while creating this, it will log into the ESX server on its own and create the VMs. These VMs will be nothing but your software defined storage array nodes. So here what you are doing, we are just using a software. We are converting the SAN to NAS in case of software defined storage array. Let's say we have allocated Hitachi storage. I'm talking about my own environment. You can do the same thing using Nutanix, using SimpliVity also. Any hyper converged network, you can use it, to leverage SDS, ONTAP select, not only ESX, okay. One of my student, Mahesh from, I think, Mindtree, I think. So he's using Nutanix, okay. His nodes are in Nutanix. My ONTAP select nodes are in ESX. So it depends. Because of giving training, right, I am able to understand multiple environment from my students, like hundreds of students I have, right. Okay, so basically what you are doing here, suppose you have made investment on SAN products, and your client is asking that we do not have any budget, but we require NAS, right, and we don't want to make a server, a Linux server, as a file server. We want to use it as a file share. We want storage level, functionalities. So what would be the solution is, you need to buy the license. The license would be as per the TB, okay. Suppose you want to make 1 TB visible in, or maybe you want to use 1 TB as a file share, right. Then what you do, you allocate the 1 TB from Hitachi to your ESX, okay, from data store, and from the data store you can use it to your on tab nodes, on tab select nodes, and you can only allocate that 1 TB, or you can make that 1 TB. You can allocate many storage, much storage, that is not a problem, but you can only make visible, make that 1 TB visible only if you have the license for that, for on tab select. The on tab select license will have like capacity here, capacity pool license. I'll talk about it in my on tab select sessions. I'll build a cluster in front of you, okay, and I also show the troubleshooting things that I have done, which will come handy during your interview sessions. I share a lot of troubleshooting sessions which I have experienced, and which my student had experienced. Okay, see, 100 students, each student will come with 5 troubleshooting. It will become 500 issues. Okay, so you keep on adding new things. Okay, so we talked about SAN, we talked about NAS, we talked about S3, we talked about SDS. NVMe is also there. We'll talk about that. Okay, in part NVMe storage. Okay, but NVMe storage is not normally used that much. Okay, so basically what you need to understand, you need to use SAN basically for your database, mission critical applications. You use file storage for shared drives. Okay, use object storage when you want to put some photos, videos, cloud backups. You can scale it to infinite. Okay, and it is mostly used for cloud. Okay, and then we'll talk about one by one. Okay, we'll talk about some performance metrics. These are very important. Okay, so at most time, right, see, in my environment I get P1 P2 only once or twice in a year, and that is mostly false positive, means it's really not related to storage. So whenever application team will face some performance issues, there's always thing, they have a very pea-sized brain, and they will think, okay, what happened, they will think that storage, what the data is coming, is being stored, okay, it's storage and it's slow, that means storage team is, the issue is storage team, like storage, right? So they will reach out to storage team. So you have to do a lot of analysis, and let them know that there is no issue with the storage and fabric switch. If they're using SAN, if you're using NAS, then in that case you also have to check, you have to trace route from your storage lifts, like storage to your server, to understand how many hops it's taking to deliver the packet, to transfer the frames. If you're using Jumbo means it's a larger frame, means it takes lesser hops. If you're sending files which are on higher sizes, like you have a small hathi, the small hathi is called small tempo, right? Bengali call it hathi. Small tempo, you have a large lorry. So large lorry can transfer more loads. A small car, small vehicle can transfer less loads, right? Similar to here also. Okay, so basically you have to, when you are talking about the performance matrix, you have to talk about IOPS, you have to talk about throughput, you have to talk about latency or response times. Okay, in my switch sessions I'll talk about what are the troubleshooting we need to do at the switch end, related to ports, related to your BB create 0 issues, which is fabric contention, the slowed down device or crystal devices, because these things will come in handy. Okay, and I talked about everything from my own practical experience. Okay, and also include cyber security for NetApp in L3. Okay, in this batch I'll teach you some hardening concepts, because hardening concepts are always there. When you're working as a server admin, you need to harden your things, right? So here also you have some hardening concepts. So when you talk about IOPS, right, IOPS full form is input output operations per second. Like let's use an analogy. Let's say you are working as a park attendant, and you're just observing, that how many cars are passing through a gate in 1 second, right? So here, how many IOPS are being processed in 1 second? Instead of car, you just mention, IOPS, input outputs, input and outputs. The IO can be a read IO, the IO can be a write IO. It can be a read request from your server, it can be a write request from your server. Okay, so you have to, like, whenever you have some latency issues, right, you need to ask the application team that, hey man, please let me know the workload characteristics and graphs of your application. So they will tell you that our IO size is small, or the IO size is big, it's mostly read, it's mostly write, it's mostly sequential read, it's mostly random read, it's mostly sequential write, it's mostly random write. And you also know the rate you are using. I'll talk about it in a second. Okay, so basically, after knowing that the IO size is small and they are facing performance issues, then you have to concentrate on the IOPS graphs. In Hitachi, we have different tools to check the performance graphs. In NetApp, we have System Manager and Occam. Okay, you have these two tools, and you also have ONTAP CLI. ONTAP CLI is also handy, especially the waffle. LT guys, please check my session. Okay, I have uploaded session for waffle performance analysis. It will come very handy during interviews. Okay, when somebody is asking you interview, right, whatever question they ask, you have to speak non-stop. You have to waste their time, so they cannot ask many questions. Okay, that's just a trick. Okay, so basically what I'm trying to say is, for IO size which is small, you have to check the IO graph. For the IO size which is big, if your application IO size is big, then you have to look into throughput, which is nothing but the bandwidth, MB per second, G per second. It means how, like, the data transfer speed. Okay, let's say you have some highways, like, what do you call, NHS something, NHS highway, right? So some highways are there, right, bigger highways. So how many lanes are there in highway, right? So it's like this. So it is usually measured in megabyte per second or gigabyte per second. Okay, so if the IO size is bigger, then you have to check the throughput, and you need to understand the throughput. Okay, so basically, if the IO size is big, you are checking the throughput, and also what you're doing here, you are checking how many HBS the server is using, and whether the host is having multipathing software, native or proprietary. Native multipathing software is basically MPIO for Windows and multipath for Linux. I don't know what they call it in AIX or HPUX, but Linux they call it as multipath. Okay, and what you need to do is, you need to ensure that that is installed, because even though you have done zoning on multiple paths, multiple HBA, multiple front-end ports, but the load distribution and the path failover in case one path is not available will be done by your multipathing software only, and that is installed the host side. 99% of the time the host team will do this, because the storage team will not have admin privilege. Yesterday one of my student Rupa was asking that, sir, how do we get more experience on multipathing software? I told her, you can read this, just go to MPI and multipath, but unfortunately if you do not have server admin access, you will not get a chance to do that. But you can always ask your server team to share your screen with you. Okay, so that's something there. When I was part of TCS, right, in I think TDC or Trade Communication project, so there we used to have access to the admin access to the server also. But after that project, I never got server access in any of the projects or any of the companies. Okay, so storage team will not have server access mostly. It's except the servers which acts as a storage management server. So here, what you are doing, you are checking the zoning. Maybe one of the path fails, maybe the switch port is faulty, It could be the SAP is faulty, so you need to fix all those things. Or maybe the fabric is having BB credit, buffer credit, zero issues, and if one of the port is having these issues, right, like one of the switch, it will impact the entire fabric. Okay. And when you see IOPS, right, IOPS is like a lot of IOPS, and your pool, storage pool is nothing but it's an aggregate of disk, while we define rate in NetApp terms. We call the storage pool as aggregate. In Hitachi it is pool, in EMC it is pool, in NetApp it is aggregates. Okay. So we need to check what kind of rate group we are using, and the write penalty will come. I will tell you about this. Okay. So let's say write, just say throughput is bandwidth. Okay, just for now remember like this. Okay. And then we have latency. Latency means how much time does storage is taking to respond to the server, and it will be measured in terms of milliseconds. Okay. If it is less than 5 milliseconds, then it's good. And if it's suppose application is which is a mission critical or high end application, it is experiencing 15 millisecond, 20 millisecond, then you have some issues. You have some issues at the storage level. But on storage end it is showing as 5 millisecond, but server end it is showing as 20 millisecond. Then you have to check outside of storage. It can be your SAN switch, it can be server level, the HBA might be outdated HBA, and server, it can process the speed, like the front end port speed, let's say it's 64 Gbps, but the HBA is only supporting 8 Gbps or 4 Gbps, then it is not able to cope up with the server speed, storage speed, right? So in that case also you will face latency issues, but it will be due to the server, not the storage. Okay. So there are different layers are there in order to, like, your application layer, server layer, SAN switch layer, storage layer. In case of NAS you have network switches, so you have to inspect all these layers to find the root cause of your performance bottleneck. They will ask you about, they will use different terms like performance issues, performance bottleneck. Okay. So latency, you need to understand latency or response times. Okay. And then you have to talk about your so basically I can also talk about the rate concept, but before we talk about the rate concepts, let me make the understand about switch concepts in a much simpler way. So you have a data center, right? You have a physical data center. Okay, nowadays what companies are doing, they are having their own physical data center, and they are keeping the data related to SOX compliances. Means the banking data, it should be in India, it cannot go to US, right? So you are using a cloud which is in different Arizona region or some other region, right? So it will go to the region, right? Your data is not it's basically it's not compliant. Okay, it's non-compliant with the SOX, right? SOX policies. So in this reason, due to this reason, what banking projects are doing is, they are having their own data structure. They are also having some little bit of cloud on the side. So they are both having traditional storage team and cloud team. Okay. And oftentimes the traditional storage team will also manage the cloud storage. Okay, like Azure Blob Files, Amazon FSx, or Amazon S3, or Azure Native Files. Okay, so they will use this. Okay, so when you have your data center, I first saw the data center when I was worked in TCS, and the data center in CUB, right? It's inside the TCS building, Velachery, Chennai, right? So I saw that it's very cold. Okay, it's like we have fingerprint service to go to the data center, and every time in the morning, and yeah. And because of the person that was there, and the same person became a very big lead, like manager in HCL, and I'll probably give a Hitachi training to HCL very soon. Not conducting Hitachi training as of now for normal normal thing, because but for like companies I'm doing it, so they have like 20 students I think in the project. So yeah, So that is the person, the person who's asking me for the data, he is the person who first introduced me to the storage. Okay, he's like 3 or 4 years senior to me, I think. So anyway, so basically, when you're talking about data center, right? So data center will have different layers. You have application layer. So here you will have your customer application where the customer will put the data or request the data. It can be a banking app, it can be a SAP app, database, it can be anything, right? Like it can be those kind of apps. And then you have a database where the data will be in tables and rows. It can be a SQL database, it can be a NoSQL database, okay, structure and structure. And then you have your server host where where you install the application, where the application will run, right? And the server will have your CPU and RAM, okay. And then you have your network part. The network part can be it can be SAN switch, it can be network switch. If you're using FC fiber channel, then we're using SAN switches. If you're using CFS and NFS, then you'll be using network switches. If you're using iSCSI, which is another protocol which is part of SAN, but here they leverage network switches, so you don't have to spend money on buying SAN switches here, but the performance will be much slower compared to FC in case of iSCSI, okay. So and then you have the storage array part. So here the physical data will actually sit, okay. This can be a physical array, this can be software defined arrays, in case of on tap select, okay, cloud array, that different things can be, okay. And there is one more important thing that you have to understand or you have to know, and these questions will often come into the in the interviews. So I'll tell you one thing: if you're working like 8 years, 9 years, 10 years, then normal interviewer will refrain from asking you basic questions. They will ask you basic questions only if you fail to answer the question they ask you, right? They will try to understand whether you have really worked on storage or not. So the people who are having less than 5 years experience, they should concentrate on storage basics more, because those questions will also get asked during the interviews, okay. So my students, they work in many different companies like CGI, Apple. I don't know about the US people, like, because their companies are a little bit different names, but I'm talking about the India. So Mindtree, TCS, Accenture, Wipro, HCL, Capgemini, uh, Fujitsu, I don't know, some kind of companies there. And uh, I think this company is okay. There are other companies also there, but I don't remember. Yeah, Infosys there. I don't remember. Cognizant is there, uh, and other companies also there. Okay, but I don't. EY, yeah, EY is there. PwC is there, mm, and some French company. Yes, but I don't remember the names. Okay, so you need to talk about the RAID. Okay, RAID is RAID. Okay, RAID is redundant array of independent or inexpensive disks. This is intel, like we use this in intelligent storage systems, okay. And we use this RAID concepts because whenever the disk fails, we don't want our storage to become unavailable, okay. And that is the reason we use RAIDs, okay. So basically, if you're talking about RAID, right, so RAID will have, it will have your fault mechanism, redundant mechanism. So whenever a disk fails, the data will still remain available to the applications, okay. So let me go to the Internet Explorer or Edge. Nowadays they call it as internal, this thing. So we'll talk about RAID 0. RAID 0 is known as striping. So here what you're doing, you're striping the data across all drives, right? So basically you are splitting the data into chunks and you're writing it across all the drives. So these are basically stripes: A1, A2 stripe, A3, A4. So you can see the data is written only once, right? So if A1 is lost, then it is lost, right? So it is having zero fault tolerance. If one drive fails, then you have data loss, right? But this gives you, fastest read and write performance, because It does not have to be written twice and more times. It does not have to calculate parity, right, parity, right. So because of which the performance for the write and reads are much faster, fastest I would say. Okay, so this is the basic RAID you need to understand. So initially this RAID was invented, and then RAID 1 came into existence. Okay, I think this picture blue color I like, this one I think better. So RAID 1 is nothing but we call as mirroring. Okay, so here data will be duplicated exactly onto two or more drives, here minimum two drives. Okay, and here it can protect you, if you're having this RAID configuration in an environment, it will be able to protect you against one drive failure. So fault tolerance is one drive. So if this drive is gone, then this drive is there, and because identical data is placed in both the drives, right? So here, because the data is available in both the disk and it can be read from the either disk, so the read performance is good, but the write performance is equal to a single disk because you're writing it twice, right? And another problem, which is a very grave problem, is you need a lot of money, because suppose you have 4 disks, you are using RAID 1, so you're using 2 disks, right? So your raw capacity is 4 disks, but your usable capacity is becoming 2 disks. So this is becoming a very expensive thing for our project, right? Okay, in case of RAID 1, because we are writing the data twice, so we are only able to use 50% of the raw capacity as a usable capacity. So during the interview they'll ask you what is raw capacity, what is usable capacity, you need to tell them. Okay, okay. So I was just speaking, brothers and sisters, so do you have any questions until now? Any questions wherever you find difficulty to understand? Any question?
No, no, that as of
Okay,
now, good.
yeah.
No,
So
Daya.
yeah. So this is mirroring, right? So first RAID
Sir,
0 is typing. Yeah,
sir, regarding RAID, RAID 0, usable capacity and drive capacity, how much, sir? And
it will be 100%. I mean 100% means almost 100%. Like it can be never be 100%, but almost close to 100%. So it's very good. You are not losing money because you are not having any fault tolerance. If one drive is lost, your entire data is lost. So it is not recommended to use it. See, we use RAID 0 only for software defined storage arrays such as on tap select. Why? Because we are getting the space from some external array which is having their own RAID, right? So we don't want to do double the RAID, right? RAID is already there in the external storage array such as Hitachi or EMC. From where we are giving the storage to ESX or any kind of hypervisor like Nutanix. Okay, so we don't want to do another RAID in NetApp, right? So at that time we are using striping RAID 0. But there is one more thing we use, with that is mirror aggregate. I will talk about that. Okay, that is something else. So as for to answer your question, RAID 0 is not having any fault tolerance, so usable capacity is close to 100%. Okay, so it is the cheapest one, I would say, the cheapest solution available. Okay, and then RAID 2, RAID 3 is there, but nobody uses RAID 2, RAID 3. Okay, so we'll go to RAID 4. Okay, RAID 4 is something which we use in NetApp. We don't use in Hitachi or EMC. We use in NetApp. So nowadays, if you guys are working in different storages like IBM, HP, right, you should learn NetApp, because most of the openings will come into NetApp and Pure. Sometimes Dell, sometimes Hitachi. Dell was quite good, in earlier days when it used to work. But after EMC, I mean after Dell acquired EMC, right, it went downhill from there. Okay. And I also had I had many colleagues which worked there for Dell, like EMC company for 10 years. They came to Accenture. Okay, so a lot of colleagues I had. But what I want to do say is storage is very easy. Storage, networking, database, any technology you can learn. You can learn development also. It's not a problem. You just need to spend some time. Okay, because I'll tell you. I'll give you an example. My brother, he did BTech electronics. Then he did masters in Amrita University. He's a gold medalist, and he did double master in France, Côte d'Azur. Now he got a PhD. Okay, and he will analyze, like he will research on machine learning on medical devices, and after PhD he will look for the research positions or something. And I've also requested if he can teach people about, after his PhD is done, about machine learning or whatever things he do. I mean whatever things he does in my platform. Okay, so the thing he does, right, it is difficult, but he didn't know this 5 years ago, right? He didn't know this 6 years ago, right? So if we spend time, and this is like infrastructure, you have to remember the concepts. You are not creating something, you just need to know how a thing is done. You are not doing any development. Okay, automation is a different part, but normal infrastructure, the manual part is very easy. Okay, but NetApp is little bit complicated compared to Hitachi, Pure, and EMC. Pure is probably the easiest one, but I will tell you, there is one storage which is more complicated than NetApp, that is CPH, but that is mostly Linux storage. That is more complicated. Okay, so here RAID 4 is there. So in RAID 4, what you are doing, we are using dedicated parity. It is similar to RAID 0, which is typing, but here we are using a, this picture is not good. This is good, this is good, yeah. So we're using a dedicated parity here, right? Okay, so we're using a single dedicated parity is to store the parity information, right? The fault tolerance is one drive. So if one drive fails, then it's okay. If two drives fails simultaneously, then your data is lost. Okay, but there is some downside related to RAID 4, because when you are updating something, right, when you are updating a single RAID, right, so maybe A1 you are changing to A1 dash, okay, or A1 to A1 2, right? Then what is happening? The parity is being calculated and it has to return across the array, right? It has to return on this disk, right? This single parity disk, right? So it is having a write penalty. I'll talk about the write penalty tomorrow, because it's a very big concepts and little bit complicated concepts. I'll talk about write penalty. I'll talk about how do you calculate the how much IOPS and aggregate can support for an application, the calculation, the mathematical calculation. Okay, I'll talk about that. Okay, also I'll talk about the the architecture, like front end port, back end port, cache architecture, read cache, write cache, I mean read it, write it, write back cache, write through cache, all these things, dirty bit flag. Okay, you just have to wait for some time. Okay, so here, because of this, so you're having some latency, right? I mean you're having some bottleneck, or you can call it latency also. Okay, and we use RAID 4 in NetApp. So in NetApp, what we use? In NetApp, we use RAID 4, RAID DP, and RAID, sorry, my left hand is having some problem, RAID TEC. Okay, so RAID 4, as I said, it uses single dedicated parity. Okay, and when you talk about RAID 5, right, I'll talk about this thing. Okay, so when you talk about RAID 5, I'm sorry, here, go here, where it is, this is a big picture, seems like a big picture here. So you can see here, it is you also have like parity here, but here the parity, right, it is being distributed across, the parity blocks are distributed across all the drives which is part of the RAID group. Okay, so what RAID 5 is doing, the data is getting striped across all the disk, and the parity is getting distributed across all the drives, right? Here also we're having one parity which is being distributed across all the drives. So here fault tolerance is only one drive, but it does not have the parity drive bottleneck which we had in the RAID 4, right? In RAID 4 we had a single dedicated parity, right? But here it is distributed, so you do not have the bottleneck that we had in RAID 4. Okay, but still it can support only one disk failure. So when the one disk failure happens, right, and and after that, in the simultaneously you got another disk failure, then your data will be lost. Okay. So RAID 4 is dedicated parity, RAID 5 is distributed parity. And then you have another more thing which is RAID 6. Okay. This is a little bit better. Yeah. Okay. So you can see here, this is dual distributed parity. It is similar to RAID 5, but it will have one more parity. The parity will be called as P and Q. So it has to calculate and store two sets of parity across all the disks in that particular RAID group. Okay, A1, A2, A3, AQ, AP, AQ, B1, B2, BP, BQ, B3, C1, CP, CQ, C2, C3, like this. Okay, so it can protect you against two disk failure in the RAID group. If two disk fails simultaneously, the data is still not lost. If one more disk fails, then data is lost. Okay, here the write penalty higher because you have to do a second parity calculation. I'll talk about the write penalty tomorrow. It has some calculation, I'll talk about that. Okay, because during the interview they'll ask you about write penalty, rate penalty. Okay, okay, but these are the RAID groups. Okay, so and we also have nested RAID groups, RAID 10, RAID 01. We'll talk about that. So basically, what you need to understand, these are the basic rates, but NetApp does not use these basic rates. NetApp use RAID 4, RAID DP, and RAID TEC. RAID DP and RAID TEC, it was invented or created by NetApp. So initially, when I started my career back in 2010 or 11, I started with Hitachi and then EMC, then NetApp. Okay, so I've been working Hitachi for many years. I know things on Hitachi that nobody, I mean, like very few people knows, because I worked in Hitachi Venture also for a long time. Okay, my Hitachi Venture, I used to work in NetApp, Hitachi, and EMC, all three things, and Cisco and switches. So basically, what I'm trying to say is, storage is very easy. Storage backup or any infrastructure domain is very easy. Okay, you just need to learn this thing. Okay, like prior to 6 years back, 4 years, 5 years or 6 years back, I did not know CVO. So CVO is a new concept that I learned, right, and which I'm using in my project, right. So everything is new. Okay, even they did not have AI or AI aware data analysis to protect against DOS attack or ransomware attack, like AI data sense, which is we are having in NetApp, right. It did not have it was non-existent few years back, right. So new concepts are having any. I'll provide 5 years of repeated sessions. Actually it will be lifetime, but I say 5 years because let's say if it does not happen, right, so people might question me, then you have promised me something, you're not delivering it, so I don't want to do that. Okay, you need to have discipline, in order to succeed in life. So what I'm trying to say is, storage is easy. So if you think NetApp is difficult, you just read the video two more times and you'll understand. Okay, so this is RAID 6. Now we'll talk about RAID DP, which is we use in NetApp. So basically, this picture is better. Yeah, so basically, for NetApp storage systems, especially on tap, we use RAID 4, RAID DP, and RAID TEC. But if you're using some array like E series, which uses Santicity OS, then the RAID we use is RAID 6. Even though it's NetApp, we use RAID 6, but that is a different thing. Okay, so on top we're using RAID DP, RAID 4, and RAID TEC. So RAID DP is double parity. Okay, it is a much more advanced version or efficient version of RAID 6. It uses two dedicated parity disks. Here it is not distributed but dedicated parity. So one is horizontal parity, like for RAID 4. Okay, similar to RAID 4, and one will have diagonal parity. Okay, and the fault tolerance will be two drives, so it can protect you against two drive failures. But unlike the RAID 6, when you want to add more disk, like when you want to increase your RAID group, I mean RAID DP size, right, RAID DP, the RAID group size, right, then what happens? Suppose you have 12 disk, you want to make it 14, then it will not, it does not need to process or calculate the parity for the entire RAID groups, right, and it's much easier to expand. So it has some limitation, some advances. Yeah, team, I wanted to say one thing that this is a free team. So after 1 hour, it will get disconnected, auto disconnected. So you have to rejoin again. So that is the catch, okay? And that is for every batch that I do. Initially, I used to do in Google Meets, and that is the reason the voice quality is low. You know, when you see the videos of 2 years ago, right? The voice quality is low, and it's because of Google Meet. Okay, but after I started using Teams, and sometimes I use Zoom also. You know, few videos will be Zoom. That was one of my students' Zoom I used to use. Okay, so but Teams is good, and the software, the recording software that I use, that is a paid software I purchase from every year. I purchase from Amazon. Okay, but I'm planning to buy. I have a student who works in Apple, right? Planning to buy Mac, but after some time, so probably the videos will be in much better quality. And one more thing I wanted to tell you is that whenever it's get disconnected, you have to rejoin. Okay, it will get disconnected after 1 hour. Auto disconnect.
Okay, okay there.
Mhm. So now let me share the screen again. 1 second. Okay. So mm, where am I here? Right. So it's having, you know, two distributed pairs, like sorry, two dedicated pairs, P1 and QQ. P1 is basically your, you know, it's basically horizontal parity, the same as RAID 4, and Q1 is basically diagonal parity. Okay, and then you have RAID TEC. RAID TEC, triple eraser encoding. I don't know the picture. I need the picture. Yeah, maybe this one is better. Mm, this is Santi CD as I was talking about. It is not this one. RAID TEC. Okay. Unfortunately, I will not be able to see the RAID TEC picture. Is not there. Unfortunately, this is a kind of RAID DP only. Like, okay, so here instead of two parity, like you have three parity. Okay, RAID TEC. TEC is triple eraser coding. I use the same concept in storage also. So triple eraser coding. So suppose you are using very large drives, let's say 10 TB, right? So when you have more drives, you will be more drives. When you're using more drives in a RAID group, more drives can fail at the same time, right? So for that you need additional protection, and that's the reason you use RAID TEC, which will protect you against three disk failure. Okay, it basically uses three dedicated drives. I mean three dedicated parity disks. One is horizontal, one is diagonal, and the last one is anti-diagonal. Okay, these are the names. Okay, I'm not able to show you RAID TEC picture because it's not in the online. So it's like you just mentioned like one more just imagine one more drives with P1 Q1, AP1 or AQ1. Okay, your anti you know diagonal parity. So horizontal, diagonal, and anti-diagonal. Okay, so here the fault tolerance is three types. So it can protect against three simultaneous disk failures. It basically uses for massive SATA or SAS drives, because when you have a lot of capacity and disk fails, then to rebuild that RAID group, it can take days also. And during that time, so let's say two drives failed, right, during that rebuild, and then one more failed, like one more fails, then you lose the data in case of RAID DP or RAID 4, right? So in this case, RAID TEC, which has a third layer of protection, third like anti-diagonal parity drives, right, it will help you to protect from the data loss. Okay, so this is something you need to know. So RAID 0 striping, it does not have any parity. RAID 1, it is mirroring, it does not have a parity, right? So minimum disk for, so minimum disk for RAID 0 is 2, okay. Minimum disk for RAID 1, which is mirroring, is 2. Minimum disk for RAID 4, which is having a dedicated parity, single dedicated parity, the minimum disk will be, for RAID 4 it will be 3. 3 means 2 data disk plus 1 parity disk, okay. 2D plus 1P, this is how we call it, okay. And RAID DP, it is having dual parity, so the minimum disk will be 3, so that means 1D plus 2P, okay, 1 data disk and 2 parity disk, okay. And if you are using RAID TEC, the minimum disk count will be 7, so you are using 4D plus 3P, 4 data disk and 3 dedicated parity disk. One is for diagonal, so one is for horizontal, diagonal, and the last one is anti-diagonal, okay. And here horizontal and diagonal, okay. This is a dedicated only horizontal, okay. And when you are having RAID 5, RAID 5 is having parity, yes, but the parity blocks will be distributed across all the drives in that RAID group, and the minimum disk will be 3, that means 2D plus 1P, okay. And you have RAID 6. So here you have dual parity, double parity, but the parity blocks, again, it will be distributed across all the drives in that parity group. So the minimum disk it will have is 4. 4 means 2D plus 2P, 2 data disk and 2 parity disk, okay. And then you have one more thing that is also you can discuss. Recently we got RAID 50 also. You don't have to know about that because you're not using it, but still you should know RAID 10, okay. This is nested disk, okay. So here what do you see here? This is what you see, A1, A1, A3, A3. What do you see? Mirroring of this, right? So this is a mirror. RAID 1 is a mirror. I know RAID 0 is stripe, right? So this is stripe of mirror. This is RAID 10. You know, this was especially I used to use, you know, in Hitachi. For databases, I used to use RAID 5 or RAID 10. Okay, in Hitachi, but NetApp will not support this RAID. NetApp only supports RAID 4, RAID DB, and RAID TEC. Okay, and in case of E series, it will be different, you know, RAID groups like RAID 6, and RAID 01 is also there. Okay, so there what I showed stripe of mirrors. Here mirror of stripes. Okay, you can see this is a striping, right? Block 1, block 2, the data is not mirrored, right? But if you see, this data is being mirrored here, right? So this is mirror of stripe. Okay, this is RAID 0+1. So some application might use this, but not for NetApp. NetApp does not support this. Okay, and you also have RAID 50. I've never used this. Okay, I've never seen this in action. So RAID 50, you can see you have your RAID 5, you know, this one single distributed parity, and then that is mirrored. Okay, so mirror of RAID 5, that is RAID 50, RAID 5 plus 0. So this is called as nested RAIDs. Okay, they might ask you this question in the interview, so you have to remember nested RAIDs. Okay, so what I'll do tomorrow is I'll discuss about the, you know, I'll begin with the write parity calculations, write penalty calculations. Okay, they will discuss, you know, they will ask you during the interview. Okay, so one more thing I wanted to talk to you about this is, you know, when you are studying this, right, for L2 and L3, so what you need to do is you start with your storage fundamentals. Okay, and then you go to the bash 20. Okay, you read there. Okay, and then bash 22. Okay, like for L3. So just read this thing. And initially when I was to give a training, right, I had a Learn Info channel. I have a Learn Info channel, so there's to upload all the videos and give individual access, right? So that's why from that channel I have downloaded and saved it here, overall sessions. But except the L3 session, L2 sessions will be quite similar, so you don't have to worry about it. So just study this thing. Okay, so let's say, let me go here. Okay, I'm telling what you need to study. So first you study the storage fundamentals, which will be the storage concepts, and Yeah. Okay, so probably the last one, I think, right? Yeah. So you need to study this basics, right? Then switch basics, switch sessions. Okay, you need to study this, and then network hardware model and how the disk shelf cabling is done, system networks, management network, data network, intercluster network, and how the read and write IO happens in ONTAP. Same thing I discuss in Hitachi also. Okay, in Hitachi, this is Hitachi, right? So same thing I discuss in my Hitachi classes, and also same thing I did, not same thing, but I also have a storage automation training. Power Max I'm creating because I worked on EMC product for a very long time, and it will be it will be good actually for me to reminisce that thing knowledge. Okay, so these are the things, so now we have done the Python part. Now into the Ansible part, right? So with rows I'm showing, these are the things I'm showing. Okay, like how to create the SVMDR metro cluster, how to the health check using Ansible, how to the on-type upgrade, all these things. Okay, and so basically mainly I'm using Ansible, Python, and Terraform. Okay, but I'll be also in using Jenkins, create some Groovy pipelines and Git, because without doing the CI/CD it never becomes real automation, right? So you have to create the CI/CD pipelines for the storage. Okay, is also how to integrate Ansible with ServiceNow. So a lot of things are there. It's very, but I didn't do many batches in automation. I did only 3 batches so far. Okay, so let me go here. So just study this thing, okay, one by one. Then service processor. Okay, so basically NetApp nodes, right? When it's not accessible, you can access to service processor, but the service processor will be there in physical arrays, not for ONTAP select. You also call it as BMC. Okay, and then shells. What are different shells are there? SVM, NIC teaming, network sessions. These sessions are difficult to master. These two sessions, okay, and very important. And then these are easy sessions: quotas, flex clone, dedupe, on-type upgrade, snapshots, QoS, auto support, snap log, snap mirror, L2 interview. Okay, then the L2 sessions is over. Then we go into the L3. Okay, wobble performance analysis. Okay, and you get 5 new sessions in L3 with every batch. Okay, so guys, do you have any questions before we wrap up for today? Any questions? And L2 is also same. Okay, I'll also show you the L2 one. Yeah, so L2 one is this one. And you guys, you can also take into training from him if you're interested. He is very good in. He worked in Hitachi, no, so not Hitachi. He worked in Comfort company and also Network Cement company. Okay, he's a very good, very honest guy and very knowledgeable guy. Okay, he will go above and beyond to make you understand some concepts. I don't know him personally. I've never met him. Okay, but he wanted to be a trainer. So one day I talked to him. I understood that he has knowledge, and then I kept him as a trainer. Okay, so Ankit is also there, but he has not delivered a single training. Okay, nowadays, because he is a senior manager in Cognizant, he's not providing training. So only me and Abdul is providing, and I'm trying to add one of my colleague, who is an AIX expert. For the AIX, like if he agrees, then we'll add him in AI for AIX. So if we go to the L2, go to the content. Okay, so here also a lot of things are there. Same thing is there. Okay, you can just study here. So first, what you need to do, you need to study the storage fundamentals, and then you need to study Bash 20 or Bash 22 or Bash 20, whichever you like. You can study this. Okay, and this is only for the Hindi people. Like somebody wants in Hindi, then it is here Hindi. So one batch I did it in Hindi. Okay, I had all peoples from Gurgaon and North. So one batch I did in Hindi, like initial days actually, not everything, but then a lot of people came in who did not understand Hindi. So I again transferred to English. So you can study from this. Okay, let's say Bash 20. Okay, let's say you study from Bash 20. Okay, so here you can study all these things. Okay, trunking, this is a very important thing. This alone can help you crack the interview, the ISL configurations in Sandswitch. So I'll talk about all these things. Okay, okay, there also I have added SVMDR. Okay, no problem. So just here non-distributed operations like storage failover, leaf migrations, view server rehosting, all these things has been explained here. Okay, OCAM issues, auto support issues resolution, QoS policies. Okay, QoS adaptive policy, fixed policy. I implemented this for one of my student who lives in Qatar, I think. I forgot his name. I forgot his name. Okay, so the volume name it came in Arabic. Okay, I was not able to understand. So I was asking him to copy paste. Okay, it was not in English. It was in Arabic, and big volume name. I was confused. Because I didn't know another language. So I was asking him to copy paste it, and he has some issues, and I created QoS policy in order to segregate the issue, like segregate the critical applications, limiting the bandwidth for non-critical applications. So I did that. See, I'm giving you training. And I'm taking money for training, like not for support, but I help you because I want to help you. For question answer, okay, and that will get lifetime help for question answer. But suppose you call me middle of the night, asking you to share your screen and do the thing. I cannot do that. Okay, that's not gonna happen because I also have my full-time job. And it's not only storage or this thing I do. I also have some other thing that I need to study. Some other thing I'm studying. Okay, not related to IT, something else. So uh, you just study all these things, okay, and like here I've talked about system backup, how to take node backup of in a tab. This is also very important. Okay, not many people knows this. I take the node backup and I have automated it in, I have kept it in cron schedule, so it will be sent to like 12 past, like 5 past midnight, to the FTP server that I have created. FTP server also have created. I have used IIS, which is a Windows feature, to create the FTP functionalities, okay, and also so those things also are done. So everything I've shown here, okay, you just need to study this, and question answer you can study this, okay. Okay, so I'll stop the session here. Tomorrow we'll connect at same time, 8 o'clock, okay.
Okay, okay then.
Yeah, anybody asking anything?
Yeah, I have a question here, Delia.
Mm-hmm.
So just wanted to know that all of these sessions, videos which are there, so we will be covering this or we have to study it from the pre-recorded videos?
No, we'll be doing live, okay. We're doing live only. Pre-recorded videos I have given to you because today's video will be uploaded in these two channel only. So from this channel only you need to see that today's video. But yeah, everything will be live only. No, it's not recorded because recorded is a different plan. Okay, I know many people will give you the videos and tell you to read it, but I don't do that. And that is the training. That is the reason the training is 3 months. Otherwise, I can complete it in 1 month and then do another batch, right? But I
Mm-hmm.
don't do that. And unfortunately my automation training is for 4 months, so it is much more longer, and not I don't know, but it also gives me a sense of sense of time to make it better, because I'll be adding Git and Jenkins, okay, in this batch, because I want to have some version control where I can put the codes and which I can pull using Jenkins, using the Groovy pipeline. Easy only, it's DevOps only, but DevOps, you are doing application DevOps, so you are deploying the Java, the jar files, or doing something. You are doing infrastructure DevOps, you are doing the cloud automations, but here we concentrated on only on the storage part, okay, nothing else, only on the storage part.
Okay.
There I teach Ansible, Python, and Terraform.
And
Terraform only for the CVO part and cloud part, and
hmm,
Ansible and Python is for NetApp, Hitachi, PowerMax, Pure, Brocket Sandwich, and CVO. And Infinidat I will not teach. One of my students will teach Infinidat, and then I will show him how to use it in Ansible, because I have no idea about Infinidat storage. Okay. And I also gave pointers to Abdul so that he can create a course for backup automation. So let's see what happens. So I'll stop the session here. You just study this. Tomorrow we'll have the same session. Tomorrow we'll begin with write penalties. Okay, write penalty, because that's a very important concepts. And then we'll discuss about front end port, back end port, cache, hot spare. Okay, all these important concepts. And once this storage basics is done, we'll go into the SAN switches,
okay,
brokered SAN switches.
Okay, one more thing which I wanted to know, that if in case due to some reason we are not able to attend the live session for that particular day, so after how much time you will upload the video for that day?
I'll upload with after I disconnect today, right? It will be uploaded within 15 minutes.
Okay, okay,
I'll
fine.
upload, yeah. Yeah,
Okay.
it's exception condition. My health is not good, something that then
Mm-hmm.
next day only, but that is exceptional.
Mm-hmm.
Normally, I never, suspend any session. Okay, normally I continue because, it's like, because, it's only 3 days or 2 days. For
Mm-hmm.
automation, I do 2 days, right? I used to do 9 to 10 p.m. IST, but because I'm doing automation at that time, I don't want to do back to back, okay? Because
Mm-hmm.
I might get some call or something, Normally, I don't have to do much work in my project, but if something is wrong, then they will call me, so that's another problem. So, but and I was planning to do like I'm not doing more badges because I need to go to office, and after some time it will become 5 days office, so that's a bad thing. But I still do. I have managed a way to do 2 days, 2 weeks office and 2 weeks work from, and that will remain depending on whether the organization policy changes. Also, that will remain constant. So I at least have 2 weeks of work from home every month. So that I have like 6 months I'll go to office, 6 months I'll have work from home. So anyway, so let's see what happens. Okay,
So
and
this will
also you
be,
need to
or
study.
will be batch number 24.
Let me think. 23, I think, right? 23.
Okay, 23. So videos will be recorded under 23.
Yeah, yeah, it will be recorded under 23. Okay, so here, how do I do this? I just create a new playlist. Okay, batch, batch 23. 23 is not a good number. Mm, yeah, and here I will add the videos. Okay, okay, so I'll stop the session here. Tomorrow we'll connect at 8 a.m. sharp. Okay, and weekly 3 days we'll have the
I have,
training. Hmm.
before ending the session, I have a question. Do you provide any lab for practicing? Is that there in the course?
Okay, so which company are you working, if you don't mind me asking? Can you disclose the
Uh,
company name?
in
Is
TCS,
it TCS, right?
yeah,
Then I'll help you with lab, okay? Just connect me after some time, I'll help you with lab, okay? Or is it possible to share your screen? I'll stop the recording. Is it possible to share your screen? Like your personal laptop also? Is it possible to share your screen?
yeah, can do.
Then I will stop the session in 1 second. Let me stop it.